Welcome students. In this part of the lecture, we will see how to design a DFA for the given language L over the alphabet sigma. Students, in these type of questions where you have to design a DFA, you will be given a language L and the language L will have this set of strings over the alphabet sigma. Sigma is a set of symbols, for example, A, B, through which the input strings are formed. That is, the language will contain all those strings, which are accepted by the DFA, whereas rest of the strings will be rejected. For example, if the language of a particular DFA is having, it implies that the DFA will accept the string A only and double A only, whereas rest of these strings are rejected. So next, we will see the designing of DFA for three different cases. The case number 1, the case number 2, and the case number 3. In the case number 1, the language L contains finite number of strings and all strings are of same length. So in case number 1, the language of the DFA will contain the fixed number or the finite number of strings and all strings are of same length. Whereas in the second case, you will learn to design a DFA that contains finite number of strings and the strings are of different length. For example, in the language, some strings are of the length 2 and some strings are of the length 3. Whereas in third case, the language of the DFA contains infinite number of strings. Let's go to the case number 1. So the case number 1 is the case in which the language which is given over the alphabet sigma contains the finite number of strings and all strings are of the same length. For example, the language of the automata contains the string of the length 1 only, that is all strings are of the length 1, or the language contains the strings of the length 2 only, or the language contains the strings of the length 3, and so on. For example, if the language given is, which is a set of strings that are accepted by the automaton W, such that W belongs to sigma star, which is set of all possible strings, and the length of string is 1. It implies that the language will contain all those strings whose length is exactly 1. In this example, the input alphabet sigma is given as a comma b. That is, all strings are created by using the symbols a or b. These are called as input symbols. Sigma star is set of all possible strings set of all strings. So it contains a string of length 0 as well as string of length 1 and a string of length 2 and so on. That is a set of all strings. So because the second condition is the string length is 1, then the automaton will have the language in which the string will be A and B. The language L will contain a string of the length 1 only. So A is the string whose length is 1 and B is the another string whose length is 1. Because the string length is 1, the states required to draw the DFA is states required here will be, because the string length is 1 plus 2 equal to 3. So in this question, we will have the requirement of the 3 states. I'm repeating, the DFA will accept these strings A only or B only, whereas rest of these strings will be rejected. So let's draw the 3 states. So this is the first state, this is my second state, and this is the third state. The first state would be the initial state. As it is clear from the definition of the deterministic finite automata, and it will have initial state, which is marked by the arrow. And from state 1 to state 2, this arrow is representing the first input alphabet. So for the first input, the machine can have the input A or it can have the input B. So on reading input A, it should reach to the final state because the input string A is accepted or recognized by the DFA. Therefore, the state number 2 is to be a final state, which is represented by double concentric circles. So this is final state. Similarly, if the input string is the B only, it is reaching from initial state to the final state, which implies that the string B of the length 1 is being accepted by this automaton. The arrow from state number 2 to the state number 3 is representing the second input. The second input could be A or it can be B. But according to the definition, if the string length is greater than 1, it should be rejected. Therefore, on input, second input A or B, the machine should go to the state which we are calling at dead state. After reaching to the dead state, if there are further inputs, either A or B, the machine should remain into the dead state. So this is the state transition diagram of the DFA, whose language is given as L equal to W, where W belongs to sigma star, that is W is the string over the alphabet sigma, whose length is exactly 1. Let's cross-check the DFA, because according to the definition of DFA, for every state, all inputs are to be defined. All inputs are to be defined. Then only we'll call it a deterministic finite automata. Look at this state 1. So for the state 1, input A is defined, that is for which a transition is given, and input B also is defined here. It's okay for this diagram. For the state number 2, which is the final state, the input A and input B is also defined, which is okay here. And finally, to the last state, both the inputs are defined. So this is the answer of this question. Let's take another example. So in the case 1, we are taking the second example. So you have to design the automaton DFA, whose language is given as W, where W belongs to sigma star, that is W is the input string, where length of the string is exactly 2. The language belongs to our case number 1 because the language contains finite number of strings and all strings are of the same length, that is length 2. So if, as it was in the previous case, if input alphabet sigma is A comma B, then the language will have the strings of length 2 as AA, AB, the next string would be BA, and finally BB. So the L is a finite set, and in this set all strings are of same length, that is 2. The state required for the DFA would be, number of states required would be 2 plus 2 equal to 4. So rest of these strings which are not part of the language L should be rejected by the automaton DFA. So let's draw the state transition diagram for this question. So this is my first state, which would be the initial state also. This is the state number 2. It's the third state, and it's the fourth state. This arrow, that is a transition from state number 1 to state number 2, is representing the first input alphabet. This is first input symbol. So the second arrow, which is from state number 2 to the state number 3, will represent the second input. Similarly, from state number 3 to state number 4, this arrow, the label of the arrow, will represent the third input. So in place of the first input, or the first character, first symbol of the string can be either A or it can be B. Whereas the second input or the second character of the string, which will be accepted by this automaton, can be either A or B. So all those strings whose length is exactly 2, that is by consuming first input and consuming the second input, the machine should be in the final state. Therefore, the state number 3 is to be a final state. So let's draw it by the concentric circles. So here, in this case, state number 3 is the final state. This is the final state. State number 1 is the initial state. So after reading two input symbols, if the machine is reading further inputs, that is the third input or the fourth input, which would be A or B, the machine should reach to a dead state. In the dead state, rest of the possibilities or further input should be trapped. Therefore, there will be self loop for the dead state. This is the state transition diagram of a DFA whose language is given in this question number 2. Let's cross-check that for all states, all possible inputs are defined or not. State number 1, input A and B both are defined. That is, if the machine is in the first state, then for the input A, it will go to the state number 2. Similarly, for the input B, it will reach to the state number 2. For the state number 2, all the inputs are defined. Similarly, for the state number 3, A and B, both the inputs are defined. Hope this question is clear to you. Let's take one more example. In the another example, let's say you have to design a DFA whose language is L, which is set of strings W, such that W belongs to sigma star and the length of string is exactly 3. In this question also, the input alphabet is given as A, B. That is, all these strings are created by using the symbols A, B. Here, A and B both are input symbols. According to the condition, the string length is exactly 3. So this L is finite or will have the finite number of strings and all strings are of the length 3. That is, the language will have the following strings. Or the combination of it. So it will have the 8 combinations in which the strings are made up of A or B. The state required to draw the DFA of this question is 3 plus 2 equal to 5. So 5 states are required. Suppose this is the state number 1, it is the state number 2, it is the state number 3, it is the state number 4, and this is the state number 5. The very first state would be the initial state. And the arrow which is connecting to the first state with the second state will represent the first input symbol. First input symbol. Similarly, the arrow which is connecting the state number 2 with the state number 3 will represent the second input symbol, and this is the third input symbol, and this is the fourth input symbol. Third input symbol. So according to the language given, the first input symbol, that is the first position of the input string, can be either A or it can be B. So by reading either A or B, the machine will reach from state number 1 to the state number 2. Similarly, the second input symbol, according to the definition, can be either A or B. And the third input symbol also can be either A or B. So by reading the 3 input symbols, the machine should be in the final states, because according to the definition, all those strings whose length, string length, this is the length 1, length 2 and length 3, it should be in the final state. Therefore, in this question, the state number 4 is to be a final state. So here, state number 4 is the final state. If there is a further input, when the machine is in the final state, that is the 5th input, the machine should reject all those strings whose length is greater than, this is the 4th input. 4th input onwards, it should reach to a dead state. where the rest of the strings, that is the string of the length 5 onwards, is to be trapped by the dead state. So this is the diagram of the state transition diagram, whose language is given as the language contains all those strings which belongs to the sigma star and whose length is exactly 3. I hope this example is clear to you. In the next lecture, we will learn how to design or draw the deterministic finite automaton for the second case, in which the language, that is the case number 2, the language L contains all those strings. Language L contains the finite number of strings. Finite number of strings, but the strings are of different length. Till then, thank you very much. Thank you for watching.